Okay, we're going to go over percent problems, and basically this is another way of looking at concentration. Usually this is done for things that are a little bit more straightforward, like you might have some hydrogen peroxide at home and really it's like 2% hydrogen peroxide. Most of it's just water, but there'll be a little bit of the hydrogen peroxide in it. And we have two main kinds. We have the percent by volume and the percent by mass. And you can see the equations. And so like here, percent by volume, it's just going to be milliliters over milliliters. And then the times 100 is just for the percent part. Or we have grams divided by grams and then times 100 for the percent part. And then we'll show how that's related to things like parts per million. So, for an example, what is the percent by volume of ethanol, which is C2H6O? It's also called ethyl alcohol, in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water. Now, please note that the formulas have volume of solute over volume of solution. So in this case, our solute will be the 85 milliliters and our solution will be the 250. So all we have to do for our percent volume over volume basically is it'll be the 85 milliliters divided by the 250 milliliters and then times 100. And this comes out to be 34%. Now, please remember that 34% as a decimal is 0.34. So that times 100 changed the 0.34 into 34, and then we add the percent sign. Okay, and that's it for a percent problem. We just took the smaller amount, the solute, divided by the total solution, and then times 100 to make it a percent. Now, we're going to do the same thing in 20. Again, what is the percent concentration V over V? Percent volume of 20 milliliters of solute when the volume of the solvent is 60. And notice that we got a little bit difference in words here. So in this one, our percent V over V is going to be 20 milliliters on top, but the bottom part is going to be 80. Okay, because the entire solution, notice that the definition is based on solute over solution. But what we were told were solute and solvent. Well, the solution, as you noticed in the video, is both of them together. Okay, so we have to add them together. And so really, this is 20 milliliters over 80 milliliters, and then times our 100, which will come out to 25%. Our decimal was 0.25. That's what our calculator will say. The times 100 made it 25%. Now, good question would be, well, you know, why didn't we do that up here? Now, if it had said, you know, 85 milliliters of ethanol diluted, you know, with 250 milliliters of water, then we would have had to add the 85 and the 250. But instead it said to a volume of 250 with water. So the water is not actually 250. The entire thing was diluted so that it would be up to 250. So sometimes, you know, you got to just think in terms of the context of what it's saying. Here we had solute and solvent, so clearly neither one is the solution. The two together give us the solution. Whereas here, to a volume of 250, that's really implying that the entire solution is 250, of which 85 of it was what was dissolved in it. And that's really the trickiest part of these types of problems. So that's the main thing. Solute over solution, Here, solute and solvent made the solution. And then it's just divide and multiply times 100. Any questions so far? Okay, number 3, we have already what the percent volume is, 3% volume. And just remember that when you see 3% as a decimal, we're talking about 0.03. Okay? So, you know, if I have percent volume over volume, well, that's going to be volume of solute over volume of solution. Well, I can rearrange that to become the volume of solute has to equal the percent times the volume of solution. So in this case, my 3% as a decimal, and then they tell me I have a 400 milliliter bottle. So that'd be my solution, 400 milliliters. 0.03 times the 400 gives me 12 milliliters. So in other words, that's how much H2O2 is actually in the 400 milliliters, 12 milliliters of it. So there I kind of went backwards. I already had the percent. I figured out how much solute was in the solution. Now question 4, it's very similar to question 2. The difference is now I have grams and grams. And again, how do I know that I'm going to have to add these two just the way I did in problem 2 is it said 30 grams of this is mixed with 90 grams of that, as opposed to saying I made 90 grams of solution. The only difference is this is percent mass over mass, so it's percent mass, which is going to be the mass of solute, and then the mass of solution. So in this case, it's 30 grams over 30 plus 90 grams. The solution is both the solute and the solvent. How do I know the solvent? It's the bigger one normally. So the water, 90 grams of water there, and then times 100 to make it a percent. So this is 30 grams over 120 grams times 100, which will be 25%. Because again, the decimal will be 0.25. I went times 100 to make it a percent. So had to add the two together, and basically the word mixed with tells me this was mixed with that, so this is not the total. The two together make the total. 5, very similar. Percent mass, M over M. Going to have 20 grams on top. Notice they tell me the solvent's 180, so that's 20 plus 180. It wasn't clear in 4, it's clear in 5 because one solute, the other solvent, the bottom is solution. So this is going to be 20 over 200, which ends up being 10%. And the decimal was 0.1. And then, similar to problem 3, in problem 6, we're going to go backwards. We already have our percentage. So we want to know how many grams of K2SO4. This is the solute. So the mass of solute will equal the percent times the mass of solution so in this case our 5% we'll write as 0.05 times the 1,500 grams, because it says needed to prepare 1,500 grams of 5% solution. So the 1,500 grams is the total solution. We end up with, we need 75 grams of K2SO4 in that 1,500 grams of solution. So first couple were percent volume, second couple were percent mass. Notice that in the top three, they were milliliters divided by milliliters. The next three, they were grams divided by grams. And then the times 100 is what made it a percent instead of a decimal. So any questions on those? Now, the last two will deal with parts per million. And if I go back up to the top, note that, mass over mass is going to be grams over grams. It could be kilograms over kilograms, but basically it's normally grams over grams. Well, that's the same thing that the parts per million is. The difference is, and then we go times a million instead of times 100 for percent. So that's the big difference. Instead of times 100, we're going times a million for parts per million. The thing is, this could be for very small amounts of solute in a very large amount of solution. There are certain elements, certain chemicals that, if we want, relatively speaking, safe drinking water, then we only want a few parts per million, if you will, grams of water to have that particular contaminant in it to still be safe. It's pretty tough to get it 100% pure, but if we only have a few parts of, say, uranium per million parts of water, then it can still be considered to be safe. Now, there are a couple other ways to do this. For parts per million, we can have milligrams per liter or grams per liter times 1,000. And the reason for a couple of different forms is because we can, instead of doing grams, we can have milligrams. Remember that 1,000 milligrams is 1 gram. And of course, 1,000 milliliters is 1 liter. So in number 7, we're going to use the fact that parts per million is grams per liter times 1,000. So we're going to use that version because what they told us was 25 grams. Now note I have 500 milliliters, but I can change milliliters into liters by simply dividing by 1,000. So 500 milliliters is half a liter. And so here my parts per million would be just 25 grams over 0.5 liters. And then times 1,000. And this ends up being 50,000 parts per million. just following the formula. The formulas will be on a quiz or test. You don't have to have them memorized. You just kind of have to know how to go back and forth depending on the information you're given. Were you told grams and milliliters? Were you told grams and liters, or kilograms and liters, or milligrams? You just have to be able to go back and forth between the different units. Now in number 8, we're going to go backwards. We are told the parts per million. We want to know how many grams were dissolved in that. So again, if we look at our starting point, parts per million is grams over liters times 1,000. And then we're just going to plug in what we're told. Well, we're told 4,000 parts per million. So I'm going to put that over here. I'm told the volume amount is 10 liters. So you can kind of see how I've matched things up. Here's the parts per million part. Down here was the volume part, the liters. I'm going to solve for the grams. How many grams was that? Now note, I got 4,000 here and I got 1,000 there. So if I divide both sides by 1,000, I now have 4 parts per million is the grams over the 10 liters. Multiply both sides by the 10. And my gram part is going to be 40 grams. So 40 grams dissolved in 10 liters of air is the same as 4,000 parts per million. So this gives you a few examples of how to do percent problems. So these are the examples, and then you have that other sheet for your homework. Any questions?